Now we're getting into some more trig identities that will be used to solve equations. So note, I will provide these double angle formulas for you on assessments. You don't need to memorize them, you just need to be able to use them. However, the Pythagorean trig identities you need to know. So if I am starting this next example, I see I have cosine 2x plus cosine x equals 0. And those are two different cosines. Now, what trig identity can I use for cosine 2x? I would use this one here. 2 cosine squared x minus 1 plus cosine x equals 0. I'm going to put this in standard form. 2 cosine squared x plus cosine x minus 1 equals 0. Looking at this, you should see a quadratic trinomial in terms of cosine, and we'll factor that by guess and check. These first two terms have to multiply to make 2 cosine squared x, and these two terms need to multiply to make negative 1. That'll be 2 cosine x, and minus 1 and plus 1. And my inner and outer smiley faces should check out. So zero product property tells me 2 cosine x minus 1 equals 0, or cosine x plus 1 equals 0. So I'll solve both of those equations over here. 2 cosine x minus 1 equals 0, and cosine x plus 1 equals 0. So first, if I isolate cosine x, I get positive 1/2. So I think about, in my unit circle, where is cosine positive? All students take calculus. Well, cosine will not be positive here. Cosine will not be positive here and here. So my two possible angles are here and here. So cosine is 1/2 for pi over 3, and this angle is going to be 5 pi over 3. So my general solution is x equals pi over 3 plus 2 pi n, and x equals 5 pi over 3 plus 2 pi n. The only way to get around to those, again, is to add multiples of 2 pi. Now here, cosine x equals negative 1. So remember, cosine is x. So where on my unit circle is x negative 1? And that is only here at the point negative 1, 0, where my angle is pi. So my answer here is x equals pi plus 2 pi n. So these double angle formulas can be used to transform our equations.